Hello everyone, welcome to Comsol MultiPhysics training course. In this course, I will teach you how to use the Comsol MultiPhysics software for modeling a chemical reaction. Regarding the Comsol MultiPhysics, I would say this software is a final element analyzer, solver, and simulation software package for various physics and engineering applications, especially cube, phenomena, and multiphysics. For numerical solution of a problem involving a chemical reaction, equations of energy, momentum, and mass, along with the equations related to the chemical reaction, must be solved. Here we will focus on the chemical reaction since the explanation of the other part is very time consuming and we will address them in subsequent presentation. Chemical reaction. Yes, to modeling a chemical reaction in Comsol software, you have to consider the chemical kinetics and thermodynamic properties. Chemical kinetics describes the rate of a chemical reaction that refers to the speed of reactant consumption or product production over the time. Several parameters uh, can affect on a rate of reaction, chemical reaction. For example, concentration, pressure, reactant state, surface area, catalysis, temperature, and orientation of the molecule. The formulation of the chemical reaction, the formulation of the reaction rate can vary based on the types and the amount of the reactant, and also uh, can vary based on the type and amount of the products. So you can see here different type of reaction and different type of chemical reaction and their relative uh, reaction rate. For example, here A and B are reactants and AB is a product. So there are two ways to define reaction rate. The first one is the using the is related to the amount of the reactant used over the time, or the second one is uh, related to the amount of the product over the time, the amount of the product formed over the time. So for this chemical reaction, the reaction rate is defined here. K is rate constant. Capital A and B refer to concentration. Small a and b refers to order of reaction with respect to A and B respectively. To calculate rate of reactions, we have to pay attention to rate constant. The Arrhenius equation is a well-known equation to define rate constant. Arrhenius equation describes how the rate constant of a chemical reaction depends on the absolute temperature, activation energy, and factor, frequency factor, okay, which is related to the collision between reactant molecules. Uh, yes, now uh, we can start to model an example for a chemical reaction in Comsol software. Today I'm going to study a plug flow reactor. So you can see here the geometry and all parameter or which are needed which are need to simulation. Here you can see the chemical reaction rate of reaction and the rate constant based on the Arrhenius equation, and all parameter related to the Arrhenius equation are provided here. This this reaction is because this reaction is an exothermic decomposition reaction. Uh, so we have to pay attention enthalpy of reaction. You can see here the amount of the mole enthalpy of reactions, and also initial temperature and initial concentration uh, for reactant are presented here or provided here. Yes, in inlet area we will have a reactant, and after heat up by a cylinder, uh, all reactant are converted to the product in outlet. So we want to simulate this uh, reaction, chemical reaction in Comsol without considering the geometry. Let's me share my screen. When you open the software, you can will face with this page here. The Windows has two options for creating a new model wizards and blank model. The model wizard guides you through the first step, through the first steps of the setting up a model like physics and study type. However, in the blank model, uh, you have to add your component and your study manually. So we are in training course, so we should select the model wizard. This page you are able to set your dimension related to your study. For example, 3D, 2D symmetry, 2D and 1D axis symmetry, and 1D and 0D. Uh, for studying just chemical reaction, we should select zero dimension. Yes. Next page. In next page, we are able to choose the physics interface are provided in Comsol software. For chemical reaction, we have two options: chemistry and reaction engineering. Reaction engineering interface is used to model several reactors during the time. However, in chemistry, you are able to access a powerful database regarding the species for modeling chemical reaction in a geometry and something like that. So, because we want to study a plug flow reactor over the time, we should choose the chemical reaction engineering, add and study. Here, we have to determine the type of our study in terms of time, uh, as I mentioned before, because we want to study a reactor, plug flow reactor over the time. We should choose the time dependent. Yes. No. This is the main page related to Comsol software. So here you can see different tabs or toolbars. Uh, for example, in Home tab, you are able to see different operational icon. For example, geometry, material, study. All these icon uh, are presented or available in Model Builder. So Model Builder is the most important tab in Comsol software because you are able to follow and see your study step by step. In Setting tab, you are able to adjust the parameter related to your reactor or geometry, and in the Graphic tab, you can see the result and geometry you build. So I'm going to start from Model Builder. So here uh, in subsequent result, in subsequent in categorized node, you can see the parameter. Yes, in parameter node you are able to define special parameter you want to change, you want to use in your study, uh, and you can type here the name of parameter and expression and the value and the unit. For example, for chemical reaction, enthalpy of reaction, you can define here, type here, and input the amount of them. In the material node, you can add the material. For example, if you right click here, add material from library. If you click here and type the material, for example water, and search, you can see the material and add the global. This icon is appropriate for adding material which you want to use in your geometry. So for chemical reaction, we will add the thermodynamic system, because maybe we will face with uh, different phases, two phases. So in following, I will discuss about that. When you choose your material here, you are able to see all parameters related to your material, and also you can add a new material you want to define by your own parameters. You can choose this blank material. Okay, enable. Okay, in the model builder, the component is most important uh, because you can see the physics interface. You can see physics interface that you are created by model wizards here. In if you uh, click on the chemical engineering, you can see here in setting tab all parameters related to your chemical reaction. For example, here you can choose your reactor type, because we want to study a plug flow reactor. Choose here. If you choose your reactor here, you can see the formulation of your reactor changes here. Mhm. Yes, and in equation form, here you can adjust your type of your study in terms of time again, and also you are able to rename your uh, study. For example, one changes the name of reaction engineering changes here. Yes, because we are more focused on we want to study a plug flow reactor. The mass balance, the mass or the volume of a reactor is not important, but if you choose another reactor, you have to define the volume of your reactor. So yes, and in energy balance, you can adjust your study in terms of temperature and external heating or cooling. If you want to add the amount of the external heating, you can write here, you can type here the amount of, and if you want to study your reactor at the uh, constant temperature, you just type here the temperature you want. Well, regarding the mixture properties, at first we have to add the chemical reaction. For this purpose, right click on the reaction engineering and choose the reaction. Yes, and type here, type the formulation A and F. Yes. Mm, mhm. uh, when you write, when you type here the formulation, you can see all species added here. Yes. Here you can choose your type of your reaction related to regard in terms of the reversible or irreversible. So because we our reaction is an irreversible, so we choose irreversible. Here you can define the reaction rate by yourself if you choose user defined. I prefer not to change. By selecting the checkbox here, you are able to adjust the parameter related to Arrhenius equation. For example, frequency factor based on our study is 10, 10, yes, 10, and the activation energy. Okay, now we have to add the thermodynamic system because in our study we have to choose the material related to a product or reactant. So for this purpose, in global definition, right click and choose the thermodynamic system. When you choose the thermodynamic system, at first you have to uh, define, you have to uh, determine the phases, type of your phases, vapor, liquid, or something like that. Yes, we choose vapor, liquid. Next, and material you want, for example, water. Yes, add, and the next one, and done. Yes, and next, here you are able to define, you are able to set the model related to liquid phase. So I prefer not to change. Yes, finished. And after that, your thermodynamics is added here, and you can see all parameters related to your material which you add. And now we have to return to the chemical reaction and check the thermodynamic system. When you check the thermodynamic system, when you select the thermodynamic uh, checkbox, you are able to adjust your reactant and product here. And also you can type the pressure of your reactor during the study here. Okay, return to formulation. Yes, because we have an exothermic reactions, so we have to define the enthalpy of reaction here, minus 100, and also because we have an external cooling, minus, I think, yes, check. Uh, okay, check here. Yes, minus 100. Minus 100. Now it's okay. Yes, now, yeah, here we have to define the initial temperature and initial concentration. So 1 and 300, the initial amount of the temperature and concentration. Check again. In species A or F, you are also able to choose your type of your species, for example solvent or surface species or something like that. And if you have more information, you can add your parameter, your information here. Now we can adjust the duration and time step here. 10 seconds is okay, and by clicking on compute icon, you're able to see the result. Yes, concentration. uh, Here I would like to plot a new graph to teach you. Yes, for this purpose, uh, you have to click right click on the result, and based on your study 1D group, and again right click on the 1D plot group and global, and in sitting windows, by choosing this icon and click here, you are able, for example, mm, choose the temperature as a y axis and the time as a x-axis. You can plot the temperature of the reactor during the time, and also again, for example, concentration, and yes, and right click here, global. mm, yes, clear concentration. Yes, and F and A. You can type here. Okay. Now plot. Yes, you can see here the concentration, all species during the time. For example, the initial concentration related to the reactant, A reactant, uh, decreases during the time, and the concentration of F increases. To export your data, the best way, right click here. The best way is to right click here and choose the copy plot data to table. After that, here you can see all data related to this figure, and you can choose all of them and copy and paste on the Excel software or another softwares. Okay, thank you for your attention.